going to be discussing microservices. The motivation for this is partly we had a Gemtalk customer that seemed interested in microservices and asked us about it. And so when the customers ask you about something, it's nice to be able to give an answer. So that prompted a little bit of research in this. And it seems like just an interesting topic with a certain amount of hype involved. And so like to be able to understand what the hype is about when people ask. So in this presentation, I've broken it up into 6 sections: the Gartner hype cycle, general discussion of modularity, the monolith, serverless computing, microservices, and then what Gemtalk or Gemstone S64 might be able to contribute to that. The Gartner hype cycle is something you may have seen before. We start out with some sort of innovation, and then that gets uh, everybody excited, and we get to the peak of inflated expectations. And hang on for the next slide. Then we when people discover that the expectations were inflated, we start falling into the trough of disillusionment. And once we reach that point, we start to find that there may be some good things in this. And so we come up the slope of enlightenment a bit more gradually than the hype, and then maybe eventually get to mainstream adoption with the plateau of productivity. So here, Gartner, this is one from August 24. So you have to pay to get their most recent ones, but you can get the earlier ones online somewhere. You can see that um, right at the headed down the trough of disillusionment is generative AI. Following behind it is WebAssembly, cloud native, super apps, AI augmented software engineering seems to be right at the top, internal development portals, and you can kind of work your way down the list of these are the things that are in a hype. So yes, generative AI is right there headed toward the trough of disillusionment. Um, so microservices fits into this category, as do many things. There was an innovation trigger in 2014 where began gaining attention. The rise of DevOps, cloud native, um, Netflix and Amazon were showcasing success, and so everybody wants to follow them into this exciting new world. But challenges come, and there's services sprawl. We discover that one characteristic of micro means that there's a lot of them. And so uh, putting together lots of different things, the deployment complexity, and people struggling. So that becomes a challenge. But eventually, maybe we discover some best practices, the tools line up to support it, the patterns mature. And rather than seeing this as something that should be used everywhere, you start to recognize that there are some appropriate places and some not so appropriate places. So maybe it gets used more effectively. And according to Gartner, we have reached the plateau of productivity for microservices. Of course, individual firms and groups and teams may go through the hype cycle as on their own, but at least in the large scale industry, we believe that this adoption is widespread, but used a bit more appropriately. Modularity is my next topic that provides some of the inspiration for the microservices. And modularity has been around a long time. The idea is we have a design principle of breaking down a software system into separate, interchangeable, self-contained, encapsulated. You may start, these words start sounding familiar of the things that we are familiar with in object-oriented programming. So modularity was a concept that came in early, and in fact, um, we will see in a couple slides here. The early programs, assembly, Fortran, were generally monolithic. You just have one set of source code, and everything is built into that. Algol introduced some control structures, subroutines, and this gave us the structured programming era. I think we had an earlier talk that mentioned Parnas, the seminal paper on the criteria to be used in decomposing systems into modules and introduced the concept of information hiding. And so some languages were built that were following that model. In the 80s and 90s, we had Smalltalk, then C++, later Java, used classes and encapsulation for modularity. Component-based software engineering, reusable components, some of these things were kind of popular as well, had their own hype cycle. The service-oriented architecture was something that was a couple decades ago, became popular. Modular services communicating over a network. And in order to facilitate that, we needed packages and some other things. So this is where we got NPM, pip, Maven, and other package managers that allowed us to have the modules that would communicate. So now we're focused, many of the current or new entrants are using packages to support modularity. It's interesting watching the Smalltalk, which started as more of a monolithic system in which everything was in the image. Um, we have classes as part of Smalltalk. Essentially, all the Smalltalks now will have some sort of packaging system, even though that's not necessarily part of the language. And so whether that's um, the Monticello, or now we're using some other things, but other languages like Rust, Go, JavaScript use packages, crates, modules, things like that. Cloud native, how is that handled? Well, there's a new buzzword that sort of combines the two extremes of now we have the modular monolith, and we'll come back to that. Serverless computing and microservices. These are going to be some of the topics we look at soon. So the benefits of modularity: easier debugging and testing because we are dealing with something that's smaller. The parallel development by teams. again, one of the most effective ways of uh, getting larger productivity is if you can put more teams on it. But we run into Brooks' law of adding people to a late project makes it later. And so you end up with this combinatorial problem of having too many people. But if you can break your system into modules, you can have people working on different parts of it. Code reuse. Again, if you could just pull in the OAuth 2 package that someone else has provided, then you're in great shape. Simplifying maintenance, updates, things like this. So, microservices is often contrasted with the monolith, which is, of course, a pejorative term that you must stay away from, according to the hype. A monolith is the single runtime executable that contains all of your code. And changes to any module or any part of the monolith requires redeploying the entire application, which can be simple or often be complex. The monolith actually does have advantages. The simplicity of development, where all the code is in one place, you can see it all in one browser, easier to set up, understand, small teams, small projects. Your basic hello world application is, in that sense, a monolith because all the code is in one place. You don't have the inter-service communication, you don't have distribution, you don't have the deployment complexity. And you can test everything in one spot. So there are definite advantages to the monolith. Performance. Making an in-process call, simply calling on the stack, is much faster than making a remote procedure call where you're going over the network. You don't have the serialization, deserialization complexity. You just make a function call. The deployment, you've got one application to deploy, one pipeline, one runtime environment. You don't need to deal with all the other complexities that are involved in microservices. Centralized management, logging, monitoring, debugging, everything is in one place and it's much easier to just deal with. But there are disadvantages, and this is where people are selling the hype of the microservices. The scalability limitations. You, if you need more throughput, you have to increase the size of the entire application. You can't just increase the resources devoted to one part of it. You have tight coupling so that changes in one part of the system often affect others. And so the maintenance becomes more complicated as you've got changes touching more sections of code. As the code base grows, bringing new developers in. Now you have this big system and they need to become familiar with more of it. More dependencies get loaded. It becomes more complicated. Deployment risks. If you're deploying and you have a bug in one part of your monolith and it crashes the process, it brings down the entire application. And this makes it, in many cases, more challenging to deploy uh, the application frequent deployments are riskier, harder to coordinate. And then when you have everything in one application, you are tied to the technology for that. Everything needs to be in one language. Everything needs to have one vendor. And these are the technology lock-in problems that some enterprises are concerned about and very cautious about. The next idea is a modular monolith. Can we take some of the advantages in one and place it in the other? So even before the microservices came, we did understand that a good architecture will have modules or libraries with function calls between them. The distinction between module and library, at least in one way of describing it, a module is internally developed where the library is externally developed, perhaps by a different team or something like that. But here we would break our application into modules and use libraries that we get from elsewhere. If we can have good modularity, this encourages a clean architecture. The modules enforce separation of concerns. So this is the architectural boundaries. Again, if you're following this modular approach, it's easier to refactor. You can make changes in one module. And if you have a very well-defined API that's and encapsulate the internals, then perhaps you can refactor without affecting others. You can extract modules into microservices later, just replace the module with something that calls somewhere else. So if you want to move in that direction, you can. The deployment is simpler. The team collaboration can be simpler because you can work on different modules with minimal interaction. But you still may have some internal interdependencies. And you still have a single point of failure. The scaling is still somewhat coarse-grained. You can't increase resources for just one module. And the discipline is a bit more challenging because you need to respect the boundaries to avoid tight coupling. And if you can see someone else's code and see their internal structures, it's sometimes tempting to take advantage of that. Serverless computing, I put quotes around it, is another buzzword, a cloud computing model where the developers build and run applications without having to manage the underlying infrastructure. It doesn't mean there's no server. It means that someone else is managing the server for you. And so you can make calls to a API that gives you some features. And much of the management is handled by the cloud provider. So the developers don't worry about managing the servers. The cloud provider handles it. The code runs in response to something like an HTTP request, file uploads, database changes. It just is event driven, and your service provider can offer the ability to scale it. So as there's more demand, more resources will be provided for it. Automatic scaling. Pay as you go. You don't get charged if you're not using it. And the functions can be short-lived. And so we now have function as a service as another of the buzzwords that come in. Common use cases, REST API, microservices, data processing for files, scheduled tasks, run this every night at midnight, chatbots to throw in the AI buzzwords, the back end for a mobile or web application. These are the common use cases. There are a number of platforms that are providing this. AWS has the Lambda, Azure functions, Google Cloud functions, Cloudflare workers, Netlify functions. So lots of people are offering this serverless computing. Again, no infrastructure management, cost effective for intermediate workloads, and easy to deploy, iterate, update, so on. Some disadvantages. The first time you ping it, it may take a little bit of a delay to start. You are going to have some limits on your execution time and memory. And of course, once you choose a platform, you're tied to that platform. So there's the vendor lock-in. And now we come to the microservices discussion. This is the architectural style where we're structuring an application as a collection of small autonomous services, each responsible for a specific business capability. And this is an important part of the definition, business capability. You should be tying it to the business functionality, not to here's, a neat way of separating it from a technology. These should be independently deployable, loosely coupled, and communicate over a network using some lightweight protocol, message queues or something. These should be composable, much like Unix or Linux commands and pipes. So you just string them together. And the definition that I think we got from Ralph Johnson or Kent Beck or someone is we compare components to audio equipment. You should be able to swap out these things and just plug in another one easily. Each microservice should have a single responsibility: user management, billing, inventory, deployed independently. So you should be able to replace, upgrade one microservice without having to upgrade everything else. Each service has its own data associated with it. So this decentralizes and avoids sharing. This allows you technological diversity. You can have different teams using different technologies, using different languages, frameworks, databases, and a failure in one service is less likely to affect others. So we typically will see an API gateway where there's an entry point that routes the request to the appropriate services. Then the services will have their individual components. The database, each service can have its own database. And the communication is REST, RPC, message systems like Kafka, RabbitMQ, these things. So the hype, the advantage, the argument in favor of the microservices is scalability. You can grow one service, just automatically apply more resources to it. The flexibility, use the right tool for the right job. We don't all have to be tied in with this one technology. Faster deployment or development. Small teams can work in parallel. There's a reference to the two pizza team. Of course, the obligatory joke here is that these are American pizzas, so the teams are actually larger than you might expect. Resilience, isolated failure, one part of the system might go down without taking everything down, depending, of course, on which part it is. But now we do have disadvantages with this, and this is where we fall into the trough of disillusionment. The complexity, there's more moving parts to manage. Operation overhead, we have to discover the services, know where they are. Now, instead of monitoring and logging one monolith, we might be monitoring many small services. The data consistency. If everybody's using their own database, then we might end up with some inconsistencies between them. And deployment, again, there's good tools for it, but it's still going to be a more complicated system to deploy. Here's some comparisons. The traditional monolith, modular monolith, microservices. For code organization, traditional monolith, not so good. If you have the modular monolith and you have clear boundaries, that's good. Microservices, much more independent. Deployment for the monolith is a single unit. Microservices independent. Scalability is a monolith is the whole application, whereas microservices we can scale per service. Maintainability, again, the more modular or microservice you have, the easier it is to maintain. The code is a little better. The traditional monolith testing is simple but can be slow. With the modular monolith, we can perhaps test the modules. And the microservices integration testing is going to be much more complicated. The unit tests may be quite easy. Team autonomy, that's where the microservice allows each team their own choices, which may or may not be a good thing. The operational complexity goes from low to high as we go from the monolith to the microservices. So, the good, the bad, the ugly, our title. The good for microservices is you have enforced modularity. You can't look over at someone else's code and say, I'd like to reach into their system. The challenge is the distributed systems have complex interactions and communication. I saw one lecture where someone from DoorDash said that they have 500 services. You have to touch 100 of them to place an order, and there's over 1,000 remote procedure calls per order. So this is complexity. And of course, being a database person, I'm going to say that database inconsistency is something that I consider a serious concern. With microservices, the ideal is we've got enforced modularity, independent teams, independent deployment. Of course, it'd be nice if it could be fast, and it would be nice if there was database consistency. So this would be the ideal. of course, now I'm going to put on my sales and marketing hat and tell you how this solves all your problems, or maybe some. Gemstone, of course, can be a classic monolith. 140,000 classes, 2.5 million methods, 35 million lines of code. This customer actually has 150,000 tests. So this is a good thing, but updating all the code at once. Discipline may give you the modular boundaries, but it's tempting to break that modular boundary. Gemstone can support zero downtime deployment, which is again a feature of the microservices. Classes and methods are objects. Data is modified in a transaction code and immediately available. So when you commit or abort, you'll see the new code. In Gemstone, each user has their own object graph available, and each object has a security policy based on owner group world. Each login can define code that's executable but not visible to other sessions. So you could put modules in a user space and enforce the modularity and the maintainability, the upgradability changes to one part don't require redeployment of the whole thing. And yet we still have the performance of an internal function call. So microservices in Gemstone, we can have enforced modularity, independent teams, independent deployment, fast with the database consistency. So that describes some of what I see in microservices and what I would recommend to a Gemstone customer that wanted to move in that direction. Questions? I think someone will bring the microphone.
One of the things you say about microservices in maybe traditional architecture for systems is that the separation of concerns is related to business
Mhm.
um, business functionality or business processes.
Yeah.
And I guess that many business processes will share the same, what we call objects. But given that they are running on a traditional database, they will create their own instances from the database, do their work and commit, and the database is what guarantees consistency between multiple sessions. Okay.
Yes.
But with Gemstone, the objects are the same in the database and in application space. So I wonder if there are specific uh, problems to solve when designing an application that way to guarantee that state doesn't leak between different microservices. How do you do that is isolation because a traditional database is a natural boundary for that.
So Gemstone does support isolating code. And so you could choose to make available an API that does not expose the source code and only allow messages to be sent to an object that's visible, where messages could not be sent to an object that's not visible.
But that means that protecting state is responsibility of the application developer, right?
It is, except it's in each application team manages their public API. And so the people that are not on your team can't see your code. And so they can only use the public API.
But you need more sophisticated developers that can take care of that responsibility.
Sure, but that is what you would have for microservices in a non-gemstone environment, is you would have teams that would have a public API and need to provide the features that are needed, desired.
You may not be able to see the other team's software, but you can run tests on it.
Well, you can send messages to objects that you can touch, but if you can't touch an object, you can't send a message to it.